Good day, sir. My name is Galan from NS1A3, and today I'm here to perform the practical assessment number 5, which is all about the solving great circle distance, initial course, final course, latitude vertex, dilo vertex, track the great circle and every 10 degrees, and total distance of the track. So let's go. So here's the scenario. You are going to determine the waypoints to use along the Great Circle Track or GCT from latitude 35 degrees north to longitude 7 degrees west to latitude 39 degrees north to longitude 74 degrees west. So the first steps that are we going to do is we will list the departure position, which is the latitude 35 degrees north and the longitude 7 degrees west. And the arrival position is latitude 2, which is 39 degrees north, and the longitude 2, which is the 74 degrees west. So in this situation, the same name is the negative and the different name is positive. So the D latitude is 4 degrees north and the D longitude is 67 degrees west. And the next step we are going to do is to find the great circle distance. So here's the formula. Cosine GCD equals close parenthesis cosine latitude 1 times cosine latitude 2 times cosine dilo, close parenthesis, plus or minus, open parenthesis, sine latitude 1 plus sine latitude 2 times sine latitude 2, close parenthesis. So in this situation, we are going to use a positive sign because we are not crossing the equator. Because the latitude 1 and latitude 2 are about the same name. So the first step is using the cosine latitude 1, which is the 35 degrees. We will first input the calculator, which is the cosine latitude 1 equals 35 degrees. And the answer is 0.81915. So that the 35 degrees is equivalent to 0.81915. So the next step is the cosine latitude 2, which is the 39 degrees, and so get the calculator and type cosine 39 degrees, and that the answer is 0.77715. So that the equivalent of cosine latitude 2, which is the 39 degrees, is 0.77715. And then we will get the cosine dilo, which is the 67 degrees. And then get the calculator and type cosine dilo, which is the 67 degrees, and equals to 0.39073. And then the equivalent of dilo 67 degrees is 0.39073. So the equivalent of cosine latitude 1 of 35 degrees is 0.81915, and the latitude 2 of 39 degrees is equivalent to 77715, and the cosine dilo is 67 degrees is equivalent to 0.39073. So we can multiply the three equivalents, so that the answer is 0.24874. So the next step that we solve for the sin latitude 1 times sin latitude 2. So the sin latitude 1 equals to 35 degrees, and to compute the equivalent of the 35 degrees is the type in the calculator of the sine latitude 35 degrees and equals to 0.57358. And so the next step is the sine latitude 2, which is the 39 degrees. And to find the equivalent of that latitude is type in a calculator using sine latitude 2 and 39 degrees, and equals to 0.62932. So the equal of the latitude of 35 degrees is 0.57358, and the sine latitude 2 is 0.62932. And after that, we need to multiply the two equivalent of the latitude so that the answer is 0.36097. So after we solve that, we will add these two. So 0.24874 plus 0.36097 is equals to 0.60971. And after that, we will press the shift and the cosine 1, and the answer is 52 degrees 25 and 53.27 minutes. So the 53.27 is we will divide the 60, and the answer is 0.88 or 0.9. And after that, our distance angle is 52 degrees 25.9 minutes. So after getting the distance angle of 52 degrees 25.9 minutes, we will solve the great circle distance. So the great circle distance is equals to distance angle plus 60 times 60. So we will substitute the distance angle, which is the 52 degrees and 25.9 minutes times 60. So type in the calculator is 52 degrees 25.9 minutes times 60. So that the equal is 3,145.9 nautical miles. So we were solved the initial course. So this is the formula. Sine initial angle equals open parenthesis cosine latitude 2 times sine d long close parenthesis divided by sine distance angle. So we will first solve the cosine latitude 2 times sine d long. So we will first input the latitude 2, which is the 39 degrees. So to find the equivalent of that degrees is type in the calculator of cosine 39 degrees is it equals to 0.77715. So the sin d low is 67 degrees, and to find the equivalent of that is type in the calculator is sine d low equals to 67 degrees, and it equals to 0.92050. And after that, we need to multiply the 0.77715 and 0.92050, and that the answer is 0.92050. 0.71537. After that, we will now find the sine distance angle. So the sine distance angle is equals to 52 degrees 25.9 minutes. So we need to find the equivalent of that. So type in the calculator of sine it equals to 52 degrees 25.9 minutes, and it equals to 0.79263. And after that, we need to divide these two numbers. So 0.71537 divided by 0.79263, and it equals to 0.90253 northwest. After that, we will type the ship sign. It equals to 0.90253, and it equals to 64.493 northwest. So now we were performing the quadrant rule. So in this situation, we have northwest. So we will have to find the northwest in the quadrant rule. So the northwest is equals to 360 minus course angle, and it equals to true course. So the northwest is equals to 360, and the course angle is 64.493, and it equals to 295.507. So that our initial course is 295.507. And the next is we will solve for the final course. So here's the formula of the final course. The sine final course angle equals to, open parenthesis, cosine latitude 1 times sine dilo, close parenthesis, is divided by 2 sine distance angle. So the cosine latitude 1 is the 35 degrees. So to find the equivalent of that 35 degrees, we need to put to the calculator of the cosine equals to 35 degrees and equals to 0.81915. So in the dilo naman is, to find it, is equals to sine 67 degrees, and it equals to 0.92050. And so that the equivalent of 35 degrees is 0.81915, and the equivalent of 67 degrees is 0.92050. And after that, we need to multiply the 0.81915 times 0.92050, and it equals to 0.75403. And after that, we need to find the sine distance angle. So the sine distance angle is equals to 52 degrees 25.9 minutes. So to find the equivalent of that is to go to the calculator and type sine 52 degrees and 25.9 minutes, and it equals to 0.79263. And after that, we need to divide the two answers. So 0.7503 divided by 0.79263, and it equals to 0.95130 southwest. After that, we need to shift sine equals to 0.95130 and it equals to 72.045. So that our final course angle is 72.045 southwest. After that, we need to find the quadrant rule. So in this quadrant rule, we will look for the southwest because it indicates to our final course is southwest. So the southwest is equals to 180 plus course angle and it equals to true course. So we will substitute the southwest equals to 180 plus 72.045 and it equals to 252.045. So that our final course is 252.045. So next, we will solve the latitude vertex. So that the formula of the latitude vertex is cosine latitude vertex equals to cosine latitude 1 times sine initial course angle. So the number 1, we will solve the cosine latitude 1. So our cosine latitude 1 is 35 degrees. To find the equivalent of that degrees is type in the calculator of cosine 35 degrees and it equals to 0.81915. And after that, we need to find the sine initial course angle. So our sine initial course angle is equals to 64.493. To find the equivalent of that, type in the calculator sine 64.493 and it equals to 0.90253. And after that, we need to multiply the 0.81915 times 0.90253 and you will get the answer of 0.73931 north. That's north because both our latitude 1 and latitude 2 are north. So the answer of 0.73931, we will put it into the calculator and add the cosine 1 and put the 0.73931 and press the degrees and it equals to 42 degrees 19 and 38.38 minutes. So that our latitude vertex is equals to 42 degrees 19 and 38.38 minutes. So after that, we will now divide the 38.38 minutes to 60. So that the 38.38 minutes divided by 60 and it equals to 0.6. So that our latitude vertex is 42 degrees 19.6 minutes. So after we get the latitude vertex, we will now get the difference longitude vertex or the D-low vertex. So here's the formula of sine D-low vertex equals to cosine IC angle or initial course angle divided by sine latitude vertex. So we will now solve the cosine IC angle or initial course angle. So the cosine initial angle is 64.493. To find the equivalent of that is type in the calculator cosine 64.493 and it equals to 0.43062. So the equivalent of 64.493 is 0.43062. And after that, we need to find the sine latitude vertex of 42 degrees 19.6 minutes. So to find the equivalent of 42 degrees and 19.6 minutes is type in the calculator of the sine equals sine 42 degrees 19.6 minutes and it equals to 0.67336. So that the sine latitude vertex 42 degrees 19.6 minutes is equivalent to 0.67336. So the equivalent of 64,493 is 0.43062 and it equivalent to 42 degrees 19.6 minutes is equivalent to 0.67336. So after that, we need to multiply these two and the answer is 0.63951 west. After that, we need to type in the calculator is sine, ship sine answer is 0.63951 and equals to 39 degrees and 45 and 19.5 minutes. After that, we need to divide the 19.05 minutes to 60. So the 19.05 minutes is divided by 60 and it equals to 0.3. So now, the difference longitude vertex is 39 degrees 45.3 minutes. So we will now track the great circle in every 10 degrees. So the first thing we are going to do is to write the departure position, which is latitude 0, 35 degrees north, and the longitude of 7 degrees west. And then we will write the arrival position, which is the latitude 8, as you can see in the table, 39 degrees north, and the longitude of 74 degrees west. So we will now track the great circle in every 10 degrees. So as you can see in our longitude, we have 7 degrees west. We will put beneath its 10 degrees west, 20 degrees west, 30 degrees west, 40 degrees west, 50 degrees west, 60 degrees west, and 70 degrees west until we reach the arrival position, which is 74 degrees west longitude, because we need to track the great circle in every 10 degrees. That's why we're going to do it. In this situation, we need to find the latitude 1, which is the 36 degrees 07.2 minutes north, which is the above the departure position of 35 degrees north. So how to get the latitude 1? So the first is we will write the longitude 0, which is the 7 degrees west. And we also need to remember that this is constant. And then we will write the longitude 1, which is the 10 degrees west. So in these rows, if they have the both same name, there will be a negative, so we will subtract it. And if you minus these two, you will get an answer of 3 degrees west. So after that, we will write the Dilu vertex is equals to 39 degrees 45.3 minutes west. So they have the same name again, and remember that is constant. So they have the same name again, so we have to subtract it, so that the answer is the Dilo vertex equals to 36 degrees 45.3 minutes west. So after we get the Dilo vertex, we move to the formula of the tangent latitude x is equals to cosine d low vertex times tangent latitude vertex. So we will now first solve the cosine d low vertex. So the cosine d low vertex is 36 degrees 45.3 minutes. So to put it in the calculator, type cosine equals to 36 degrees 45.3 minutes. So that the answer is 0.80120. So now we will solve the tangent latitude vertex. So our tangent latitude vertex is equals to 42 degrees 19.6 minutes. So that is constant. To find the equivalent of that is type in the calculator tangent latitude vertex equals to 42 degrees 19.6 minutes. So that the answer is 0.91078. So after that, we need to multiply the two answer so that the 0.80120 and the 0.91078, and that the answer is 0.72972. So after that, we need to type in the calculator of the tangent. Shift tangent is 0.72972 equals and degrees, and that the answer is 36 degrees 7.7 and 8.32 minutes. And after that, the 8.32 minutes is divided by 60. So the answer is 0.2. So that our latitude 1 is 36 degrees 07.2 minutes north. So as you can see, we have successfully solved the latitude 1. So now I will show you how to solve the course 1, which is the 295 and the distance of 161.43. So to get the course 1 and the distance 1, we need to write the latitude 0, which is 35 degrees north. And we also write the latitude 1, which is the 36 degrees 7.2 minutes north. So in this situation, if they have the same name, we need to subtract. So if we subtract these two, we can get the DLAT of 1 degrees 07.2 minutes north. And then we will multiply it by 60 so that the 60 is constant. So that the answer of DLAT is 67 degrees 12 minutes or 67.2 minutes north. So the next step is we will solve the DLO. So first, we write the longitude 0 equals to 7 degrees west. And then we will write the longitude 1, which is the 10 degrees west. So in this situation, if they have the same name, we will subtract it. So if we subtract these two, we will get the DLO of 3 degrees west. And now we will multiply the 60, which is the constant. So that the answer is DLO equals to 180 west. So now we will be solving the MP equals log open parenthesis tan open parenthesis latitude divided by 2 plus 45 2 close parenthesis times 7915.7 minus open parenthesis 23.3 times sine open parenthesis latitude and 2 close parenthesis. So we will now solve for the MP of the latitude 0, which is 35 degrees north. So to get the MP of the latitude 0, you can type the formula at the top. So the answer is 2230.92. So next is we will solve for the latitude 1, which is 36 degrees 07.2 minutes north. So that the answer is 2313.16. After that, we will minus these two and we get the DMP equals to 82.24. And the next is we will solve the true course, and that the formula is the tangent course angle equals to d low divided by dmp. So we need to substitute the d low, which is the 180, and the dmp, which is the 82.24, so that we are dividing it to 180 divided by 82.24, so that our tangent course angle is equals to 2.18872. And after that, we need to shift tangent equals to 2.18874, and we get the answer of the course angle equals to 65.44 northwest. And next, we will be solving for the quadrant rule. So in quadrant rule, we need to find the northwest. So the northwest is equals to 360 minus course angle equals to true course. So that we need to substitute the northwest equals to 360 equals to course angle, which is the 65.44, and equals to true course. So that the 360 minus 65.44 is equals to 294.56 or 295. So that our true course is 295. So next, we will be solving the distance. So the formula of distance equals to d latitude divided by cos course angle. So we need to substitute the d lat and the cos course angle. So our d lat is 67.2 divided by cosine is 65.4. So that our equivalent of distance is 161.43 or 161.4 nautical miles. So our final distance is 161.43 nautical miles. So that I will successfully show to you how to solve the course, which is the 295 and the distance of 161.43.